All right, how we doing? So this is our day 2 of when we were doing LCM and GCF, which was our lesson 3.2. So here's your warm-up today. So go to the back of your math comp book, find a clear spot, don't start a new page, and let's start our warm-up. So we have 1, 2, 3 questions. So just like our exit tickets, read the directions. This isn't telling you to pick one. You're to answer these questions, okay? How can you write the prime factorization and find the greatest common factor and least common multiple of two numbers? So our response here should be the latter method. So if you remember, we've been taking a couple numbers, say it's 36 and 12, we find what they have in common, and we'd say like 2, and then we bring the ladder down. So how many 2's go into 36? 18. How many 2's go into 12? 6. And then we can go ahead and say, well, these are both even again, so I can pull out another 2. So how many 2's go into 18? 9. How many 2's go into 6? 3. And then you could say, well, these are both divisible by 3. How many 3's go into 9? 3. And how many 3's go into 3? 1. So where do we find the GCF? This vertical piece right here, that's my GCF. Where do we find the least common multiple? It's kind of the boot or the L that we make. So again, GCF is 2 times 2 times 3. We multiply those numbers together. So 2 times 2 is 4, and then 4 times 3 is 12. That's our greatest common factor between 36 and 12. It's the largest number that divides evenly into 12 and also divides into 36. That's what GCF. So what's our least common multiple? So what we mean by that is I'm counting 12, 24, 36, and then I'm counting 36, 72, I think it's 108 if I'm counting by 36. So what's the lowest common multiple when we add these together? So we find that as we do our L, and we take those numbers. So we'd have 2 times 2 times 3 times 3 times 1. So 2 times 2 is 4, 4 times 3 is 12, and then 12 times 3 is 36, 36 times 1. There's that multiple. And you can see it here too. But we can always use the ladder method. We'll find both of them. Okay, so now let's write the prime factorization of each number. Remember, for a number to be prime, it's only divisible by 1 in itself. Example is like 7. 7 is a prime number. What numbers go into 7 cleanly? 1, 2 doesn't, 3 doesn't, 4 doesn't. So it's really just 1 and 7. That's the best way we can break down 7 as multiple or factors of 1 and 7. So it's prime because it's only 1 in itself. Can we break down 33 as prime factors? So you start thinking prime numbers. Well, like does 2 go into 33? Does 3? Does 5? Find those prime numbers, and you should be able to identify 3. 3 goes into 33. How many times does 3 go into 33? 11 times. Then you would say anything go into 11 cleanly? No. So there's our two numbers. The prime factorization of 33 is 3 times 11. And the way I can check this, I can do 3 times 11. That equals 33. Checked my answer. Now what about 32? Let's put our 32 in our ladder. Okay, what prime number goes into 32? 2. So how many 2's go into 32? 16. And then 16's even, so I can pull out another 2. How many 2's go into 16? 8. 8's even, so I can pull out another 2. How many 2's go into 8? 4. 4's even, so I can pull out another 2. How many 2's go into 4? 2. So we were able to pull 1, 2, 3, 4, 5, and that would give us 33 is, its prime factorization is 2 times 2 times 2 times 2 times 2. So again, my answer to 33 prime factorization was just 3 times 11. So the answer of 32 is 2 times itself, 5 times. And if you want to check it, you just keep multiplying 2 times 2 times 2 times 2. If you did that, you're going to get that to equal 32.